यस गाइस हेडफोन यूज करो. Yes, good afternoon to all. Today we will going to see the our next topic is physioelectric effect. Okay, so this is our lecture number 3 for module 2. So, what do you mean by basic physioelectric effect? Whenever you applied any force to any material, for example, here mm, uh, physioelectric material, for example, crystal structure, uh, then the when you force is applied, means stress is applied to that material, so there are accumulation of charges on the body of the your crystals. So it means it generate the mm, potential across that. So actually this material are available in two modes. First is natural and second is synthesis. This synthetic type. Okay, so this physioelectric, first of all, see the definitions. This physioelectric effect, transducer is work on the physioelectric effect. Okay, so this material is one which an electrical potential appear across the surface of the material. Means whenever you apply the force, there are some hmm, uh, electron are there which is loosely bonded. Whenever the force is applied or stress is applied on the body of that crystals or material, then the potential that electrons are excited and they are accumulate on the body of that, means when the force is applied on that body, which electron is uh, left their shells and move to the other side. So at that position, you can say at that point, the positive charge will be developed, and on other side the negative charge will be developed. So you can take out the potential from these two. But this is the uh, uh, this effect, this overall effect is called as a effect. And the same, this transducer work on this effect. Okay, so if you applied this force at once, so you get, मीन्स दिस प्रोसेस इज वेरी फास्ट. अगर आपने एक बार उसको अप्लाई किया, सो जो आपका जो इलेक्ट्रॉन है वो वापस जाके is come back to the its original position. So at that time the net charge or potential you get at output is zero. So that's why we need to supply continuous this force on that material. So you will get the able to get the potential across from that material. So physioelectric transducer जो है, in that you does not need any external energy sources is required for their working. So that's why it's called as a active transducer. LVDT is called as a passive transducer, right? Last lecture, in previous lecture we already seen that. But this transducer is called as a active transducer. Okay, and one more thing is the reverse process is also happening here. When you give the potential into any this crystal like physioelectric crystals or material, then you will get able to get the output in terms of mechanical stress or potential or temperature and acceleration, that which the parameter which is depending on that, you can able to get the reverse as well. So today we will see the stress applied is a force, and what are the equation, and we will do some numericals depending on that. Okay, so first of all, let's do the derivation. See, this is a cubic like crystal. As you seen here, whenever the stress is applied on the surface of that crystals, For example, this is force is applied on that, then the accumulation of charges are on the body of this plate. So as you see here, this is a distance which is I consider here the thickness of this is t. Okay, and the force is applied on the top of the that body. So according to that, this potential are created, right? So you just taken out these charges in terms of this potential, which is considered as V output of this material, for this material. Okay, so this is your output voltage. Now as you see, this structure is just like a parallel plate capacitor, like. So the charge formula is Q is equal to CV, right? So here C is the this piezoelectric crystal material to CP, which is parallel plate capacitor, and V is a output voltages. So I can so this is nothing but here CV. Okay, so when you can say that this is your output and this is your input. So charge is a function of force. Charge is directly proportional to the force here. Charge is directly proportional to force. If I remove this proportionality constant, so I need to add some constant here, which is I consider d. Now this d is nothing but the charge density. Whenever you apply the force, so for each force you get some charge density. For example, this is for F11 forces. So for that you get some charge density from here is D11. Okay, the same way, number of forces applied into different dimensions. So you will get the different dimension, this charge density at different dimensions. Okay, so what it means, this charge density is proportional to, is depending on the uh, direction of force applied. Means it is a directional dependent parameter. Okay, so if I consider uh, mm, net charge density or resultant charge density of your crystal is d is nothing but your under root of square of all charge density available on that crystal. Okay, so this is nothing but your from this from this is d11 square plus d22 square up to number of density which is available for the for particular crystal. Okay, so this is one. Now see the units for this charge density क्या होगा, यूनिट क्या होगा बताओ, what are the unit of this? Yes, this is for your coulomb per newton. So see, in this book there are some natural physioelectric materials are given, which is nothing but your first is example of एग्जाम्पल क्या है इसके, फर्स्ट इज क्वार्ट्स, सेकंड इज रॉचेल सॉल्ट, एंड थर्ड इज दिस बैरियम टाइटेनेट. And one more is ceramic AB. This is for your natural piezoelectric crystal. If I talking about synthetic type, is one is ammonium diphosphate. So this is just the information for you. Now see the relation between these two. This is one equation which is Q is equal to CV, or okay, this is one equation actually. Okay, let's see. And second one is D is equal to Q by F. Okay, let's change this notation here. This is for general equation. Okay, Q is charge is equal to C into V. So let's define in terms of E. Now that E, I rewrite that equation in terms of Q by Cp. This is a potentiometer capacitance. Sorry, piezoelectric capacitance, not a potentiometer. Now, mm, now put that this equation, which is second equation, from that from this equation, put the value of Q to this dF by, and what is the value of C? Capacitance. General formula for capacitance क्या होता है बताओ? A by D, right? Epsilon C is equal to epsilon naught A by D. So put that factor, that value to this, which is nothing but your epsilon A by D. A by D means what are the D factor here? D is nothing but your T. Okay, epsilon A by T. Now this is your permittivity, this is your permittivity, and this is your thickness. क्या हुआ? Okay, now rewrite this equation, multiply by this t factor going into the numerator, then return back to the left hand side in denominator. So E by T is nothing but your D by epsilon into F by A. Now tell me, from this equation, what you understood? What is that? Tell me this factor. Pressure, right? And this is for your output voltages, which is I just taken at E, right? So output is a function of your input. So we set the relation in terms of pressure, which is nothing but your E by T is nothing but your D by epsilon into P. So this P is nothing but your pressure term. Okay. Now uh, you can also define, means there are so many books, they are treated this factor as your in terms of G. Okay. So this G is nothing but your mm, voltage sensitivity. Voltage sensitivity. So this is nothing but your G. So this is for this permittivity you can also define in terms of epsilon naught epsilon r, right? So this potential divided by thickness is nothing but your G into P. So this is your output voltages is nothing but your GPT. This is a famous equation. So many numerical will be framed from these equations. Okay, so this is your output equation. I just changed the this notation, which is E here. Earlier, I will take the E V naught, so you can also put here E naught. Okay, so these are the one of the basic equation for from this physioelectric transducer, and depending on this G parameter. Okay, so most of the question, this parameter is not directly given to you, so you need to identify that. So how to identify? Depending on their SI unit. Okay, so let's define the unit of this G is nothing but your E by PT, right? In terms of unit, in terms of unit, so this is nothing but volt, volt, and this is this is nothing but your pressure, right? Pascal. So you can say that uh, Pascal, right? And T for thickness in meter. Okay, so this is for, sorry. Okay, so this is a one unit. For this, you can also define this unit in terms of Newton meter. So what are that? Volt per meter divided by Newton. How it get from this equation? See, from this. This is volt per meter, and this is your G. This term is nothing but your G, and this is force is Newton, and area is meter square. So when you solve it, this meter get cancel out, and this is volt meter per Newton. Okay, so depending on this voltage sensitivity, uh, if in question is not mentioning directly, then you need to identify, and its unit is also is not fixed. Okay, because sensitivity you can also define in terms of change in output and change in input. Sensitivity is nothing but your change in output upon change in input, as we see in our last lecture, that is lecture number 6 in first unit. Okay, so according to that, if mm, number of transducer is increases, for example, there are two transducer is used, that is a primary transducer and secondary transducer. So at that time, this is a primary transducer for some measurement. Okay, and this is for the secondary transducer. This is for secondary transducer. So for each transducer, it has its own sensitivity. So this is for sensitivity 1, sensitivity 2. So, and the system sensitivity is also different. So depending on the different kind of transducer you are using, so input and output quantity are also changing. For this physioelectric transducer, your input quantity, let's say, forces, right? Force is in terms of newtons, and output voltage is in terms of this voltage. And if I talking about the LVDT transducer, so there you need to measure the distance, right? So, and input is a voltage for their excitation. So that are depends on different types of mm, means these are dependent on your on your structure, means at what type you are going to uh, do the operation, right? आप किस एप्लीकेशन के लिए यूज़ करोगे उस पर वो डिपेंड करेगा, उसका sensitivity and the factor which is depending on that, which is you provided as a input and taking as out. So these are the concept for this mm, piezoelectric transducer. And one more thing, you can also define this equation in terms of Young's modulus concept also. So as you see that concept, if you see that concept, the same thing, but uh, but is that what are the okay? So Young's modulus का फॉर्मूला क्या होता है? Stress upon in this stress upon strain. Okay, so this is your stress upon strain. Now, okay, so how to define this stress? Force upon area and strain, change in length upon original length. So simple put that here, strain in denominator, so change in T upon change in T upon T. That is your stress here. When you solve this, you will get Ft divided by At, and the unit is Newton meter square. Okay, now the same way you can put that value. What is your force here? Rewrite this equation. Charge is nothing but your, for this crystal, if we are taking the different uh, density, these are the charge density, right? So force is also defined in terms of this charge and force, this charge density and force. So q is nothing but your d into f. यहाँ से भी इसे डिफाइन कर सकते हो. So this is the unit is coulomb per newton. Okay, and the same way for this force, you can rewrite that equation. F is nothing but a into e, which is del t by t. Okay, actually thing this things is comes from this. हाँ, कर सकते हो आप. So solve this, put actually just put this value from this equation. So this is nothing but your q into f. F का formula क्या है, ये है, right? So put that all values to this equation. Now in this is come from your Young's modulus, right? E. So the output voltage, let's define here in terms of E naught, which is nothing but your Q by Cp, right? So Q value you will get from this equation, which is D into area into E. So let's remove this into sign, नहीं तो confuse हो जाओगे आप. Okay, so this is del T divided by Cp into T. So what are the Cp? Cp formula is same, epsilon A by T, right? So put that value to this equation. So you will get this epsilon is defined in terms of epsilon naught epsilon r, which is A by T. Now this is Qt divided by epsilon r epsilon naught A. This is nothing but your D, charge density, right? Epsilon r, epsilon naught into F by A. T into P. सिर्फ सब्सटीट्यूशन किया है इसमें, ओके, इस वैल्यू का, यहाँ पे जितना भी हमने कंसिडर किया ना उसका. सो दिस इज अ सेकेंड वे बाय विच यू कैन फाइंड आउट दिस ई नॉट इन टर्म्स ऑफ जी टी पी. इस पे इसको ई नॉट से डिनोट किया कि आप कंफ्यूज ना हो. दिस इज योर फिजियो इलेक्ट्रिक आउटपुट voltages, put voltage, okay. Now equivalent circuit for this in this book is given to you, which is consider this crystal barium titanate, and this is Rochelle salt quartz. The same crystal is used in this book. The output is taken from this point, and the equivalent circuit also given in this, which is represent in terms of this C1, R1, and this is L1, and this is your CP. So हमने अभी तक जितना भी फाइंड आउट किया, this is this is your CP, right? So this is your CP. Actually, this circuit, okay. So this circuit is, this parameter is because of this arrangement, okay. This arrangement. If I consider this only this crystal, then what are the equivalent circuit for that. इसके लिए आप क्या होगा इसमें, this is your E output, okay, which you will get, and this is your CP, and this is your some external resistances which is associate uh, from that your combination. So ऐसा सर्किट बनता है उसका. And such types of piezoelectric crystal are available in two form. First is circular shape, and second is this cubical form, okay. So if I consider in circular form, so you need to take the output from that, okay. For that you are adding the this wire connection, you do the wire connection from this. So in that, if you taking the output with the help of these two connections, so there also some capacitance are present between these two wires. So that capacitance is called as stray capacitance, okay. So this is called as stray capacitance, and that also be represent in your equivalent circuit. This is called as your stray capacitance, present between these two. And leakage is also present for this, that is a leakage resistance is also present, okay. But this value is very high. Practically it absorb 10 is to power of 11, or this is value is very high. So generally observe in terms of 10 is to power of 11 ohm. So we generally avoid these resistances, because uh, current always follows the least resistance path. So it has a huge resistances, so current can't flow from the circuit, and the circuit equivalent circuit for this is रिड्यूस टू, एक्चुअली जब आप ये कनेक्शन करते हो ना, तब आप इस आपका ये जो सर्किट है, this circuit will be modified and your circuit will looks like just like that. This is your RL, means leakage resistance, and this is your this capacitance. Okay, so this is your load, this wire capacitance, or you can say leakage capacitance, and this is your uh, at your load side output voltages. Okay, generated voltage is different, which is E naught, but we are mainly consider while solving the problem this physioelectric potential, okay, or voltages. So this is actually leakage resistances. Because of it value is very high, so we can neglect that resistances because both are connected in parallel. Okay, as you see here, both are connected in parallel, so current can't flow from the load resistance side. Okay, so I just remove that resistance here. So this is your CP, and this is your RP, and this is your CL. Okay, this is for just sake of your knowledge. Okay, so this is the equivalent circuit. Now, if you see in this book, there are not so many information is given. There are only limited information is given in that, but you can just take the concept from the basic equation, and the working is also mentioning here. And this piezoelectric transducer is work in the, sorry, okay. Let's start some numericals. Write down the questions. A dynamometer arm, or dynamometer arm makes contact with this. PE means piezoelectric load. Okay, piezoelectric load cell. The G constant is 550 into 10 to the power of minus 3 volt meter per Newton, and the surface area of the cell is 4 centimeter square. If a torque of 20 Newton meter is applied to the dynamometer, then the output voltages of the cell is, so these are the mm, that arrangement. डेटा आपको गिवन है, नोट डाउन कर लो डेटा जब तक. The area of this plate is 4 centimeter square, and this thickness is 1 mm. torque is nothing but your 20 Newton meter here, and distance between this is zero point 0.5 meter. Yes, guys. Yes.
Class is this?
TMI measurement.
Second year,
Second year W.
W, electrical.
Yes.
Sir, we have a small announcement to make committee related.
Okay.
Is it possible that we make it now, or should we come back later?
So you can take it.
Yeah, so, hi guys, my name is Sharal. My name is Shriya. And we represent IEEE here. And we are opening up for sector executive positions. And these positions will be open up for takes. There are close to 30 positions. It's pretty less on your notice groups to the CR. Yeah,
Yes, guys. Please note it down this question. Yes. What are the data is given to you? A dynamometer arm makes a contact with a this piezoelectric load cell, and the G constant is given to you, which is nothing but your 50 into 10 to the power of minus 3 this volt meter per Newton. Okay, so this is nothing but your G, which is already mentioned in this question, and the surface area of the cell is 4 centimeter square. Okay, so convert that all units in meter square. Okay, so, and if the torque is given to you is 20 Newton meter, apply is applied to the this dynamometer, then the output voltage V naught of the cell. So we already seen the equations. So V naught is how to define this V naught in terms of GPT. Okay, so don't be confused. For this question, the question is specified in terms of V naught. Okay, that's why we put here V naught. Actually, this V naught is nothing but your output voltages. Okay, and this GPT P is nothing but your pressure. Okay, so you can define this. You need to find out the uh, voltages, right? So pressure is not given to you, but you can define force in terms of force, right? So this is nothing but your P F by A into T. So depending on the data which is provided you, you just use that equations. So this is nothing but your P by F by A. Now, how to find out F? See, torque is given to you. Okay, torque is given. Yes, torque is given to you. So torque is nothing but your force into this distance. So simple. This is 20 Newton meter. Okay, and F into zero point 0.5 meter, which is distance is already given in your question. Okay, so कितना आता है उसको कॉल कैलकुलेट करो. So this F is nothing but your 40 Newton. Now simple put that value in this equation and find out the V naught. Calculate करो, unit conversion proper करो. Okay, this value is given in terms of mm. So G value is given to you is 50 into 10 to the power of minus 3, and F is 40, and what is the value of T is 4 सेंटीमीटर स्क्वायर, राइट? एरिया की वैल्यू कितनी है? 4 सेंटीमीटर स्क्वायर। कन्वर्ट इट टू द मीटर, which is nothing but your 4 into 10 to the power of 4 minus 4 meter square. And what are the this thickness is 1 mm, which is nothing but your 10 to the power of minus 3. When you solve this, you will get 5 volt. The second question, write down this question, and or you can directly solve that question. Okay, see the question and write down what data is given to you. A quartz crystal Young's modulus is given is equal to 9 into 10 is to power of 10 Newton meter square, has a diameter of 10 mm and the thickness of 2 mm. You need to find out the applied volt load, means in terms of force, and the voltage sensitivity constant is given 4500. See the unit here, unit is given volt per micrometer, and this unit is not which we are seeing the constant here, right? Different है ये unit. So you need to match that unit and use that quantity in your original equations. So hmm, okay, so this is take this question as your homework. Okay, and try to find out the applied voltage for this. We will discuss in next lecture. Thank you guys.